Hi everybody, welcome back. So far in this plumbing lecture, we've covered how the water gets to your plumbing fixtures. We've covered how the water is used in those plumbing fixtures. Now in this video, we'll talk about how it leaves your building. And this is called the Drain, Waste, and Vent System, or DWV. All right, and it involves getting the waste water, liquids and solids, out of your building. How does the DWV, or Drain, Waste, and Vent System, differ from your water supply system? Well, the water supply is pressurized. Waste pipes, on the other hand, are not pressurized. They have to slope so that the contents, everything that's going through the pipes, can flow by gravity alone. The waste piping must be larger because they are carrying solids and liquids. And finally, and very important for this, there's got to be a way to prevent sewer gas from flowing back into the house in this example, or any building. Let's trace that drain, waste, and vent system as it flows through, in this case, an example of a house. We'll start at a typical fixture. Let's start at this bathtub right here. All right. And as the water flows out of the bathtub, it's going to go into the smallest diameter drain piping. All right. And then that will feed into branch pipes that get larger and larger. All right. The waste is then going to flow into a vertical pipe that's called the soil stack right here. For residences, it's usually 4 inches diameter, and that's going to carry the waste down to the house drain. All right. Then it's going to exit the building and go into the horizontal pipe. This is our drain pipe, our house drain, and that will connect to the municipal sewer system, typically, or it could be a septic tank system. Let's take a closer look at the same system. All right, in this case, we're just looking at one bathroom. And starting kind of at the same place at a bathtub, so our wastewater is going to flow through there, go through a P-trap. All right, it's going to connect to, in this case, the main soil stack. This is a smaller building. Looks like they used a 3-inch soil stack. All right, and then to the main house drain and to the municipal sewer system. Right? The other piece of this drain, waste, and vent system are the vents. In this illustration, they're colored gray. All right, and so you can see that each fixture has a vent line also, and that's going to go up and extend and vent through the roof. Moving to your multi-story, larger buildings, the drain, waste, and vent system is conceptually the same, but might be a little bit more complicated. Let's take a look at the left example. This is called a one-pipe system because all types of wastewater, including gray water, which is just liquid waste and comes from sinks, all right, and wastewater, which could include solids and comes from toilets also. All right, they're all taken out by the same system, one pipe. All right, as opposed to the two-pipe system, which could be used in larger buildings. And this separates out the gray water, all right, coming from sinks from the black water or the waste water coming from toilets that includes human waste. All right, and the gray water is often then routed for landscape use. One other difference in these illustrations than the residences than we saw before is that there are multiple vents. You can only travel so far with your vent pipes and horizontally, and so therefore you're probably going to need multiple vertical vents in your larger buildings. Let's move on to talk about some of and the first one I want to talk about are stacks. What are these? Well, they are vertical pipes in the system. And there's two names for these. One is a soil stack, and that's going to specifically carry soil waste, black water, wastewater. All right. And that's opposed to a waste stack that carries soil from sinks and not from any of those. It does not carry human waste. All right. Let's talk about traps next. The purpose of a trap is to prevent sewer gas from flowing back up into and this is disgusting, but it also prevents rodents from entering via the sewer pipes. All right. Traps are typically a U shape or P shape, and therefore they catch water in the bottom and creates that seal. So if you look over here in this illustration that we've seen before, here's an example of a trap right here for this bathtub, and here's one for this sink. You typically need a trap for every fixture, and they're in the drain pipe just below the fixture. But wait a sec, in the last illustration, there was no trap for the toilet. Well, it turns out that most toilets have a trap built into the fixture, so you don't need to provide one in the piping. Right? Let's take a look at this fixture right here. You can see that this piece is the trap. All right, and so just that dip or that U shape will create the water seal. Moving on to the vents are there to equalize air pressure and prevent the trap from being siphoned, from all the water being pulled out of it. Traps only work if they stay full of water. All right. And if we eliminated the vents and just connect the piping, it's going to be completely sealed, and the water flowing down the piping sucks that little bit of water out of the trap. And therefore, it's just air, and the sewer gas could enter our building. The secondary purpose is out of our building and allow any sewer gas to escape. Vents are typically installed in the walls behind the fixtures, and so you can see them in this illustration as the dashed lines coming from each fixture. All right, and then joining up to the main soil stack, it extends to vent up through the roof. Thanks, everybody. In this video, we covered the drain, waste, and vent system, what it is, what it does, and some of its major components.